In this video, we're going to look at now using the discriminant. We didn't really use the discriminant in much detail in National 5 compared to what we're going to do now. And what this now allows us to do is it allows us to prove that quadratic curves and straight lines, or actually any sort of intersection happens, and it allows us to actually find the point of contact of that. So the three types of intersection that we can have are when we've got a parabola and a straight line cutting at 2 points. When that happens, we say that the discriminant value b squared minus 4ac is bigger than 0. So similar to when a quadratic cuts through the x-axis, if it cuts through at two different places, then the discriminant is bigger than 0. Whenever I have a straight line and quadratic cutting at two places, the same thing applies. When I've got tangency occurring, i.e. when a line cuts through a parabola only at one place, then that's when our discriminant b squared minus 4ac is equal to 0. And whenever we don't have anything happening at all, there is no intersection between the parabola and the straight line, then it's whenever the discriminant is less than 0. Okay, so those are three main facts that really sum up how we work through quadratics here. Okay, and you need to commit these three situations to memory. Okay, and as it says in the box here, and please make sure you highlight this in your notes, the most common use for the discriminant is to show that the line is a tangent to a curve. Okay, very, very important. Example 14, it says, show that the line y is equal to 3x minus 13 is a tangent to the curve y is equal to x squared minus 7x plus 12, and find the coordinates of the point of contact. So the first thing I want to do is actually bring together my equation for my straight line and my equation for my quadratic together. So for that, I want to do y equals y, because I want to know if they intersect, and if they do, where. So that's going to give me x squared minus 7x plus 12 is equal to 3x minus 13. So that will give me x squared minus 10x plus 25 is equal to 0. So what I've really got here is a quadratic to factorise. Now there's two parts to this question. The first part is showing that the line is a tangent. And then the second part is finding the coordinates of the point of contact. Okay, so we'll call this part here just part A, showing that the line's a tangent, and then part B is actually finding the coordinates of the point of contact. So we're doing part A just now. We bring it together, the parabola and the line, make them equal to each other, and simplify. What I now need to do is show that this line is a tangent. I can do this by simply factorising this quadratic that I now have, and if I get equal roots, because this is what happens whenever tangency occurs, we get equal roots. If I get equal roots, then that alone is proof that it is actually a tangent. So we'll go ahead and factorise. Let's go to the side and do that. So 1 times 25 is 25. So I want two numbers that multiply together to give me 25, but will add to give me negative 10. So I'm thinking negative 5 and negative 5. So that will give me x squared minus 5x minus 5x plus 25 is equal to 0. So that'll be x bracket x minus 5 minus 5 bracket x minus 5 equals 0. So I get x minus 5 and x minus 5 equals 0. There I go. This is what I have. I've got my repeated roots. I've got my x minus 5 equals 0. Okay? So that will just solve to give me one value, x equals 5. Okay, and that's what happens whenever you have tangency. you only have one point of contact. I only have one point of contact here. And because it's a show that question, we must always give a sentence. So I can say, therefore, since we have equal roots, line is a tangent. Okay? Then we can continue on and do part B. I want to find the coordinates of the point of contact. Well, I've actually nearly done that because I have one point of contact. That happens whenever x is 5. So I can say when x equals 5, then all I want to do here is sub it into the straight line equation. That's the easiest one to sub it into. I get y is equal to 3 times 5, take away 13. So that will give me y is equal to 2. So I can say, therefore, point of contact is 5, 2. Okay? This is a very, very common question to get asked to prove tangency and then find the point of contact. So please make sure you're super familiar with doing this. Let's look at example 15. This time, I want to show that the line 4x, y is equal to 4x minus 5 does not intersect the parabola. So first thing we do is y equals y. So I get 2x squared plus 3x plus 3 is equal to 4x minus 5. Okay, so let's simplify that. So I get 2x squared minus x plus 8 is equal to 0. Now, to show that a line does not intersect the parabola, what we want is to think of this situation here, where my discriminant for this to happen has to be less than 0. That is my proof that there is no point of contact. So it's really all about looking at the question and picking out those keywords. So the key word about not intersecting, that's our clue. Use the discriminant. Okay? So I can't even if I try to factorise that, it won't factorise. So let's go ahead and pick out the values of a, b, and c. So a is equal to 2, b is equal to minus 1, and c is equal to 8. So let's put it into our discriminant. So if b squared minus 4ac, I'm going to get negative 1 squared minus 4 times 2 times 8. So that'll be 1 take away 64, which is minus 63. So I can finish this off by saying, therefore, since b squared minus 4ac is less than 0, y is equal to 4x minus 5 does not intersect y is equal to 2x squared plus 3x plus 3. Okay?